Hey everybody, BTO Pro here. Trying to make this make sense. It's my first go running through what this does. I'm sure there'll be more videos to come. So I've expanded upon the concept that's discussed in this unbundled components thing. So, I mean, it's like a 7-part series you can read through. But the big thing is we ship all of our elements as their own individual imports, and then the magic script kicks in. And the magic script siphons off the DOM for undefined tags and then dynamically imports their definition. So effectively, we have one build routine regardless of application, so long as it uses web components. And we do that for all of them. So I had an idea for some tweaks to it, because I've always wanted to do it. So an issue with the current methodology is it waits for the DOM to load, hits it and goes, what's undefined, then matches the registry and just imports it, which is great for our apps unpacking. But let's say that I'm on a phone and that phone is low on power, or I just really want to ship the app in a way that is going to only render, like, say, that thing way below the fold when you actually view it. Well, right now, it's going to import the definition of, like, let's say, meme maker that's way down the DOM, even if it's 20 pages down and you haven't scrolled to it yet. So this idea I've been working with called replace tag. So the idea with replace tag is you import the definition of replace tag, and replace tag's job is to know what it is to become. So I've got this working. So I have a demo here. First of all, I'm going off of this article as far as some of the replacements and consideration. So this is a really good article. It goes into just some of the different ways you can detect a device. They talk about it in terms of, like, hey, this is a way that you could know that you've got a poor device or that it's running out of power, things like that. It's pretty cool. So I've taken that, and as part of it, I should say, it talks about dynamic imports. So, all right, let's combine the magic script with that. So I've got a document here. I'm going to load it. We'll see generally what happens. This is a debug message. So I scroll down, and this element here, right, comes into the viewport, gets replaced. Now this one tells you specifically it won't be replaced. Let's inspect and see why. So it's a tag called other count. It doesn't have a definition. So I actually put it there to make sure that it doesn't actually load. Now as I keep scrolling down and we look in the DOM here, we'll see there's a replace tag. So the definition of replace tag exists. It has a shadow root, right? But it says replace tag with meme maker, and it has all the attributes required for meme maker to load appropriately. So as I get to there, it imports the definition and loads it. So this is a huge gain on top of what was already a huge gain. Now, let's do some throttling. So we can change the behavior of the browser and have our web components react to it. So looking at, before I throttle it, let's look at what is in there. I have replace tag with word count. So this is the baseline method, right? And it's going to unpack, and then it's going to import this light DOM into the new tag, right? So it's basically just taking word count and injecting it over top of replace tag. These other ones say with method view. So that implies you must see it. It has to be seen, and then it'll go get the definition. And that's critical for what I'm about to show. So I'm going to take this. We're going to throttle to fast 3G. And we'll hit refresh. And the fun thing is, if I hit navigator.connection, which is available not on all browsers, but a lot of them, it's going to now tell me I'm on 3G connection, even though I'm not on a 3G connection. Okay? So that's important. I am on a 3G connection as far as the JavaScript is concerned. So now let's see what happens as we scroll down. Now, there's a lot of other dependencies. That's because I've got a demo running here. So imagine it's gotten like 2 dependencies as opposed to the 84 it's claiming. So as I scroll down, that file's loading. See, it's starting to get the different template files. And then when it imports, the rest of the elements that were undefined as well, they self-import. Now let's find one. So we scroll down that isn't going to do that. So as I scroll down, now, because the replace tag has detected that I'm on a poor connection, it doesn't actually load up meme maker until I engage with it. So imagine I'm delivering the app to you You're on a phone, you're scrolling through my blog posts, and I've got some silly meme because I always post them. This will just detect that your phone, for example, is below 25% power and not plugged in, and not ship you the web component definition for Meme Maker until you tap on it, does loading, hey, there it is in place. So let's look at what happened above as well, as far as how this is functioning real quick. So we're going to go into, we've got replace tag. Replace tag loads up some styles that are just some global setting of styles. This is how we're able to get the outline accurate, and I'll show it in a second on things. So let's take off these with method view. So we'll just do the last one will be with method view. Now that means it has to be seen in order to be engaged in this way. So we're going to let it run. Once it gets to about 84, it'll paint. Okay, 82. So I'm going to scroll down. All right, we see we have tap to loads, right? So these are tap to loads. Now, if I scroll all the way down to that last one, because it has a forced intersection observer, right? So you could actually use this methodology, have your application still say, look, once I'm visible, I have to load, right? It could be very critical for the document working. Maybe it's the entire wrapper if you use this at every layer all the way down, which is something I'm going to play with. So as I scroll down and I hit that one that has to load, those green bars wrap around the outside because of those those style classes. Then what happens is once the definition loads for one, which is a promise being resolved on that import for the tag definition as a web component, it then fires off a call and says everybody else that was undefined previously with that same tag, it's safe to render you now. So let's get rid of this view, right? And we have pop-up loader, which I'm still messing with that. So let's get rid of that one. Okay, so the page is going to reload. We're going to get to our 80 some odd definitions, 82. Okay, 82 and paint. All right, so now we've just got tap to load for everything. Everything is tap to load because it's got this replace tag and because it's detected I'm on a poor connection. So now I can go in here and we'll just do that one and it'll turn into a loading sequence and then it'll replace itself. These ones do not because that's not how they were designed. However, if I tap and engage with one of them, all of them engage because they know that they're that tag. It's pretty awesome. So here's what's going on under the hood here. So I'm pulling in those styles. It's the things that do like the green bars around stuff. I'll do a blog post just about that at some point. Then I reference auto load. And auto load is our auto loading methodology. Now, specifically for this demo, I'm not calling a JSON file. For demos, I set up that I can actually inject the definitions into a tag just so I can mess with it locally. But in a production environment, this will just be a single script called build.js that'll figure this out. So in replace tag, we've got superclass, which is doing most of the work, but the actual tag itself, right, it has a shadow root and it just has a little like loading statement. So that's how we get the difference between loading ... and click to engage or whatever. So this is just very minimalist, like, hey, make it so that you can, hover over and tap and it has some visual feedback. So what's going on in the element is nothing in constructor. Then we've got connected callback. It says evaluate replacement method. Evaluate replacement method fires off a call to this global CSS loader, which basically detects all of the areas that are not currently defined. And then we'll do that nice little like trace around so that as you click it, it does like a tracing to say like, hey, something's going on here. So you get visual feedback during the import of the JS modules. Then when they resolve, it snaps it into place. So in that, this is fun, this is crappy. In that, we have method view. So imagine that this is now the default behavior is test and see if we're on a terrible device. So I will want to make this a singleton just so that it's not making these calls all the time. But so what we do is let's imagine that it is just one of those tags. It's running through. It says, all right, I wasn't told that I specifically have to be viewed, which would be an intersection observer. So make sure we have navigator. If we have navigator and we have device memory, see if they have enough memory, right? So this is gigs. So they have less than a gig, that's a crappy device. In this case, we have hardware concurrency. They have less than dual core. That's a crappy device. Can we pull the battery? If we can, are they not charging, which means they're not plugged in, and the battery is below 25%? Then it's a crappy device for these purposes. Then we also have, is the connection effective type, which again is platform specific, but is it something that we can target? If it is, like it's slow, it's 2G, 3G, something older, right? Then we know that we want to ship it our assets. Also, if the user has said, there's a box you can check and say, like, I want to save data. So if you have data saver mode on an Android device, I can actually use that to ship you less JavaScript assets on the fly. So now we've got, after this, we go, okay, it was crappy. Cool. Set the loading statement to say, hey, you got to tap to engage this, and then set a click listener. And then this check will get bypassed because it's crappy. If it's not a crappy device, institute the laser loader property or attribute, which does a little ray tracing thing around the edges. Change the message to say loading, because it's loading, and then set an intersection observer. So setting the intersection observer, we are just basically saying, hey, whenever we get an intersection callback, and we do it every quarter second or something, just for sanity's sake. If what we just got is that it's more than 25% visible, so you're scrolling down, you're starting to see just the edge of it, then it'll go, oh, you crossed the threshold. Get rid of the intersection observer and then run replacement. So run replacement is going to say, make sure we have a width attribute. Just delay for the sake of some visual effect that there's like, hey, we're loading. So it says loading, right? So you'll scroll down and say loading so they can actually see it instead of it just doing that and being jarring. So, okay, so wait 250 milliseconds. Then we're going to ask the registry, which is going to have the import. This is going to go and do the dynamic import. So this is what our build routine just does. It kicks out this file. Every tag right now that is picked up in the mutation observer that's undefined is going to run through this, and it'll just automatically import its definition. So this is the fun part. So we say, hey, go import the definition of this tag. It might already exist. We don't actually know, but let's just say, hey, go import this definition. It's going to go do a JS module's dynamic import. Then what we can say is custom elements dot when defined and the tag name. So this is a promise. This will return a promise to us when this is fulfilled. And that promise is only fulfilled once the JavaScript modules associated with that tag name have been resolved, because they'll call window.customelements.define tag name and point it to a class. That will only resolve once that class is there, which only comes in once we've actually imported the asset that contains it. So then, because our promise is fulfilled, run through this element we're currently in, right? The one that's in the DOM, that replace -tag with equals whatever, it has all the other attributes. Look through the attributes, set the attributes to a just basic properties observation, like take the node value and set it to a value of a attribute. Then create an element called with props.with, right? Because the with property or with attribute that was in the page is going to be the new tag name. So make a new tag name off of that, which we know came across right there. Then we're going to loop through and set the attributes on the new tag to match what was on the old tag. Get rid of our little laser loader thing, copy the inner HTML over, and then run replace with, which will take our current replace with tag and just overwrite it with this new one. Then we set a very slight delay and we remove the animating attributes from the thing. So it's coming into focus. It replaces itself. 250 milliseconds later, the animation stuff fades away. So we'll be able to have it show up and kind of fade in. And some of them you can see it's hard with the meme maker, but it'll fade in and then those attributes get ripped off. So that you have a nice easing effect to the thing showing up in the page. I think it'll be really effective with like images, particularly when you set the height and width ahead of time. So if I say this is a block area of the page, it's 200 by 200, and then I tap it and it goes off and it does the import and actually gives the thing and it fades in, I think it'll be really effective. So then the last part, once we've resolved one definition, it's safe to do it with all of them. So this promise was never going to be set on the other like elements that you need to view or click. And it'd be really annoying if you had like 20 images and you had to just keep clicking through these tags, I think, because I've made the connotation of I want to get data. Like I'm saying, tap, give me more data. So then query the document, look for replacement tags with equals the props.with, which will ensure that I have all of these tags that already have a definition because they're the same as my definition. And then I'm just going to forcibly run the replacement callback that's on those elements, right? Which is this function. It's a little trippy, but it's going to run this function because eventually this call isn't going to have anything come across, and so it'll just stop. So you're not going to get an infinite loop out of this, even though it's a little weird. But what it'll do is that bypasses the intersection observer resolving. It could be off screen, but something that I'm now visually in scope and I have 25% of it viewed, just got the definition, replace that. Now all these other things, I can just replace them. So that is the bulk of the replace tag element and what's going on with it. This theoretically will work with anything. I'm actually going to start trying it in an experimental configuration with Hack CMS. I want to see if I send the user the response and I basically do a preg match where I match the web component name and then I shift onto that. I basically replace all the closing tags with replace tag. And then all the opening tags, I replace the name of the tag with replace hyphen tag with equals, and then stuff the previous component name in there. Everything else should just work. And if that's the case, then I have shipped Hack CMS to an unknown device, and that device has then told Hack CMS, hey, I'm running out of power here. What can you do for me? And then it's up to Hack CMS and this routine to make that decision on the fly. So the theme wrapper, maybe the theme wrapper that actually gives you the design, it says, look, this has to be here, right? So it's a visibility thing. Maybe the buttons at the bottom of the UI to get to the next page, those are visibility driven. But maybe when I go and request from the back end and I'm about to parse through and put text into the page, maybe all of that is replaced with tags. And then it's up to the browser, client-side device. Do I take this information and as they scroll, see it and then import it? Or do I wait until they engage with it because they're running out of battery, they're on a much older device, what have you? So, we could also do this with older versions of Firefox or something that are on a newer device, but they're like slower or something like that. Probably wouldn't. But did want to show this. So if you want to look at the code for it, it's not published out to NPM just yet. It's over in our mono repo under something called replace tag. And so in the replace tag directory in our mono repo, you can see what's going on there. It's vanilla-ish. I'm also thinking it's possible we could have a build routine where we just pull in all the vanilla JavaScript modules that do this initial time to first paint type of a thing, basically speed that up, so that we don't need to request WC registry, this tag, the replace tag, and the dynamic import manager. That stuff just gets injected into the page. In Hack CMS case, it's there. In our index.htmls, it's just copy and paste this compiled form, but that then hits all the other assets in an unbundled mechanism. So if you want to learn more about our project, you can go to hackstheweb.org. It has nothing about what I just showed, but I'm sure it will in the near future. So catch you later.